Welcome. In this video, I'm going to be working Algebra 2 Quiz 5.4, which is about the polynomial factor theorem, which basically told us that a given binomial is going to be a factor if it divides cleanly, if there's no remainder when we run it through synthetic or long division. We also seen evidence that that comes when the polynomial is equal to 0 also. Okay, so we're going to determine whether x minus 2 is a factor of p of x. And we're going to use synthetic division because, dividing by x minus 2 is, divided by just x minus a number. So I'm going to copy the coefficients, 1x to the 4, negative 2x to the 3, positive 1x to the 2, negative 5x to the 1, and 6. And I'll be dividing that by 2. Okay, and since I got 0 here, I know that p of 2 equals 0, or when I divide p of x by x minus 2, I get a remainder of 0, so I know it divides cleanly, and I say, yes, it is a factor. All right, in the case where we're given one factor and we're asked to find the rest of them, we're going to run the first factor through using synthetic division and then hopefully be able to factor whatever we're left with. So 1x to the 4, 2x to the 3, negative 19x to the 2, negative 8x, and positive 60 divided by x plus 5. I need to put negative 5 through there. Multiply, add, multiply, add, multiply, add, multiply, add, and if at this point you don't get 0, you need to double check your work, because that means that you've made an error because one of the factors is given. So what I'm left with is x plus 5. After I've factored it out, I'm left with x to the 3 minus 3x to the 2 minus 4x plus 12. And yes, this is something I can do group and factor on because it's got 4 terms and it's got kind of that parallelism. 1 to negative 3 is the same ratio as negative 4 to positive 12. So let's start in on factoring that. Okay. And then I see a difference of 2 squares. Okay, and I've got it fully factored. I had 4-3 polynomial. I broke it down into 4 linear factors. That's as good as I could hope for. All right, here's one that's a 3rd degree, but it's not something I can do group and factor on because that ratio of 1 to negative 6 is not the same as 12 to negative 8. So it's a good example. I'm thinking I set up for synthetic 1x to the 3, negative 6x to the 2, positive 12x, and negative 8. Divided by x minus 2. So drop it down, multiply, add, multiply, add, multiply, add. Okay, so I've got the x minus 2 that I just factored out, and I'm left with an x squared negative 4x and plus 4. This is further factorable. X squared minus 4x plus 4, that's x minus 2 times x minus 2. And so you could have left it like that, or you could kind of have collapsed it down into 3 powers of x minus 2. All right, number 4 asks what value of k makes x plus 3 a factor of this polynomial right here. So we're going to set up for synthetic division. So it'll be 1x to the 3, positive 4x to the 2, kx, and negative 9. We're going to divide by x plus 3, so we'll put negative 3 on the outside. And then when I go to add these together, k plus negative 3, these aren't like terms, so I just have to keep them separate. K plus negative 3, that's k minus 3. Just making sure I did that all right. Yeah. Then I multiply k minus 3 by negative 3. Negative 3k plus 9. You add those things together, and I'd get a remainder of negative 3k plus 9 minus 9, so it's negative 3k, And if it is a factor, okay, that means that the remainder equals 0. So that means negative 3k needs to equal 0, and that can only happen if k was equal to 0. This last one, okay, it's going to give me a double factor. Okay, so if x squared minus 4 is a factor of p, well, x squared minus 4 is equal to x plus 2 times x minus 2. So I know that both of those are factors of p, so I'm going to run both of them through synthetic division to get this down to a quadratic, and hopefully it'll be easier from there. So I'm going to copy in the coefficients of p, 1x to the 4, negative 2x to the 3, negative 7x to the 2, positive 8x, and positive 12. And then I'm going to be putting positive 2 and negative 2 through synthetic division, because I've got x minus 2 and x plus 2. So I'll just start with positive 2, I guess. Negative 14. Makes negative 6, positive, nope, negative 12, and 0. Okay, that's good. Because if I didn't get 0 there, that would have been a sign that I made a mistake. And then I'm just going to do synthetic division all over again. Run negative 2 through this time. I'll get 1 times negative 2 is negative 2. Add these together, multiply them, multiply these, and I get... All right, so I factored out an x minus 2 first, and then I factored out an x plus 2 with those two layers of synthetic division. And I'm left with 1x squared minus 2x minus 3 and no remainder. And then I think that quadratic on the right, this trinomial here, I can think of two numbers that multiply to negative 3 and add to negative 2. That would be negative 3 and positive 1. So x minus 2, x plus 2, x minus 3, x plus 1. And that's as far as I can go with that one. All right, on form B, we're going to start by determining whether this thing is a factor, and so we're going to test it on synthetic division. 1x to the 4, negative 2x to the 3, positive 1x to the 2, negative 5x, and positive 6. We're going to divide by x plus 2. And we're going to see what the remainder is. If the remainder is 0, then say yes, it's a factor. If the remainder comes back not 0, then say no, it's not a factor. So negative 4 times 2 is positive 8, 9, negative 18. This isn't looking good. Negative 23? I don't remember getting this when I made the key. Let me look. Well, I guess that should be a positive 46, but otherwise, yeah, this is what I got the last time. It's 52 in there, and since this remainder of 52 is not a remainder of 0, I'm going to say, hey, no, this is not a factor of p of x. Right, here one factor is given, and we're going to factor the polynomial completely. And one big error that we saw a lot when we were grading these quizzes was people forgetting the original factor they were given, right? And okay, for 3 polynomial, you're expecting probably 4 linear factors in this class. But a lot of people were, dividing out the x plus 5 and finding the 3 other factors, but forgetting the original copy of x plus 5. And that would not be factoring the polynomial completely. So we're going to set up for division. 1x to the 4, 1x to the 3, negative 21x to the 2, negative 1x, and positive 20. We're going to divide by x plus 5. Okay, we get 0 again. If you don't get 0 when they tell you it's a given factor, then you've probably done something wrong. Yeah, and so I've got x plus 5 factored out, and what I'm left with is this quotient right here, x to the 3 minus 4x to the 2 minus x plus 4 with no remainder. And then this thing right here, that's got 4 terms, it's got parallelism, it's looking pretty group and factorable. So I think about the first 2, and the second 2 I would need to factor out a negative 1 to get an x minus 4. And then I'll factor out the x minus 4. I'll be left with an x squared minus 1. That's a difference of 2 squares, and I can keep going, but that should be it. And so again, so what I was saying earlier, don't forget that original factor of x plus 5 in there, because that's a factor of the given polynomial. So yeah, we see we've got 4 linear factors, so we know we're done. All right, on this one, we've got one factor given, and so I'm just going to do like the other ones where they give us one, set up for synthetic division. At first I was thinking maybe we could do grouping factor on this one without even doing synthetic, but I'm looking at it in 48 to negative 64 is not the same ratio as 1 to negative 12. So we're going to have to do synthetic. So we're going to divide that by x minus 4. That'll be positive 16 times 4 is 64. Okay, great. And so I've got my x minus 4 that I just factored out, and what I'm left with is an x squared, negative 8x, and positive 16. So I can think, what are two numbers that multiply to 16 and add a negative 8? Oh, that's negative 4, negative 4. And so you could leave it like that if you wanted to, or you could collapse them down and say that's 3 powers of x minus 4. All right, now they're asking what value of k makes this thing a factor. Okay, so if this thing is a factor, then it's going to necessarily have to be the case that the remainder needs to equal 0 when I divide f of x by x plus 4. So I'm going to say 1x to the 3, positive 6x to the 2, kx, negative 12, divided by x plus 4. Multiply a negative 4 by k minus 8. I get negative 4k plus 32. And if I add these things together, I'll get negative 4k plus 20. Right, so if it's a factor, then this thing needs to be 0, the remainder. We'll say negative 4k plus 20 needs to equal 0. Negative 4k equals negative 20. I'll divide both sides by negative 4, and I'll get that k is equal to 5. All right, and this last one is, well, there's one like this on the other form, but it's where it's a 4-3 polynomial, and you're given a double factor, because we know that x squared minus 9, that can be factored down into x plus 3 times x minus 3. Oh, wait, whoops. I already had a parenthesis there. Okay, so I'm going to use that. I'm going to run, divide p of x by x plus 3 and by x minus 3 using synthetic, and then hopefully the quotient will be something I can factor a little bit more. So I'm copying the coefficients of p of x, 1x to the 4, negative 1x to the 3, negative 11x to the 2, positive 9x, and positive 18. And divide by x minus 3. Got a remainder of 0, that's good news. That's straighter. No, did not have any success, but it's alright. I'm going to divide by x plus 3. Okay, it divides cleanly, so I've divided by x minus 3. I factored out an x minus 3 first, and then I factored out an x plus 3, and after doing both of those, what I'm left with is an x squared minus x minus 2. And that's something I can definitely factor. I can think of two numbers that multiply to negative 2 and add to negative 1. That would be negative 2 and positive 1. And that is fully factored. And let's see, that's all for this quiz. Thanks for watching. Hope this helped.